Hello, we're going to take a look at qualitative analysis today. And so let's take a look at if we were going to be in lab, which we might still be able to be. This was what I kind of have planned for the final exam. This is the cation version of qualitative analysis. And I tend to like these flow charts better than I do instruction number one, instruction number two, number three, number four, because it helps you to see the overall picture. So basically, you are going to be given a solution of three ions, and those three ions, there we go, and those three ions are silver, mercury, and lead. And notice that they all are written as ions, so that means they would all be soluble, probably in the form of nitrates, because of those three ions, that's going to be the most soluble form. And so what you do first is you add, get rid of, he's covered up my, you're going to add cold HCl. That would just be basically room temperature HCl. And all three of them will precipitate. And then if you heat the solution, the lead chloride will actually dissolve. So then you would filter it, and what would stay in the filter would be these precipitates. And then you double check to make sure that if you have lead, you're going to add chromate, probably potassium chromate, some soluble form of it, and you'll get a precipitate of lead 2 chromate that's yellow. And so that would be your confirmation test. Yes, you have lead. Then you would take the two solids and you would make a pH greater than 7 by adding ammonia. And so we now know with Le Chatelier that whether or not you have acid or a base, it does change the reaction. That even goes clear back to chapter 5 when we did the oxidation reduction reactions in acids and bases. And then now we're doing it with one that forms an equilibrium, because these are mostly slightly soluble substances. And so they're going to have KSP values, and you can affect those KSP values by either adding acid or base. So this one, we're going to start off by making the pH greater than 7 by adding ammonia. And what will happen then is you will get a complex ion of the silver. That's the complex ion. And so when you filter this, the black precipitate of a mercury, and then the mercury amino chloride is white, and that's going to be your confirmation that you do indeed have mercury. And then here you have the complex silver ammonia ion. And now we're going to acidify it to drive the equilibrium the other way and make it react with the chloride that is also present. And then that will give you a precipitate of silver chloride. So that's how you go through these charts and figure out what to do. I'm going to put a couple of different charts on there and kind of ask you questions just to see how well you can interpret them. This one is cations, and there's some that are much more elaborate than this. I'm not going to get too crazy with it, but I do want to kind of spend a day or so, a couple of days doing that, just so you can kind of get an idea of how to do it. Then we should have the decision of whether or not we're going to return to school in May. And if we do return to school in May, we'll cover, well, actually, I'd like to do several labs. And that's probably where we'll end up. But if we don't return, then we'll be doing, I think, electrochemistry next. It'll be what I'll hit. So you got a couple of flow charts to go through, and I'm going to ask you a couple of questions and say, if you did this and this happened, what would you do next? And, those sort of questions. Just make sure you're understanding how to do the flow charts.